Okay, the factor theorem. The factor theorem states that x minus a. The factor theorem states that x minus a is a factor of the polynomial p of x if and only if the polynomial evaluated at the point A is 0. In math, we don't like to write a whole lot, so this part of the statement is sometimes shortened to double F if and only if. This means that the result works both ways. So if you know that x minus a is a factor, then p evaluated at that point is 0. Conversely, if you know that p evaluated at a point is 0, then x minus a is a factor. So it works both ways. Our goal is to find values of a that make our polynomial 0, because that is our x-intercepts. The integral zero theorem describes the relationship between the factors and the constant terms of the polynomial. The theorem states that if x minus a is a factor with integral coefficients, so integer coefficients, then a is a factor of the constant in the term. So this is going to be how we determine what numbers should we test in order to find divisors that give us a remainder of 0. We're going to find the constant and look at what are factors of the constant and use those as our testing numbers. Another strategy we're going to use is factor by grouping. You all just did pre-cal 11, so you should be very comfortable with this. One of the key points I want to mention, though, in order for factor by grouping to work, it is important to have an even number of terms and to factor them in groups of 2. Okay? So, in general, this is kind of an overview of everything we're doing today. In order to factor a polynomial completely, we are going to use the integral theorem in order to find possible integers for the x-intercepts, or the zeros. We will apply the factor theorem to determine what is the factor. So this tells us what is a. This tells us the factor x minus a. And then we use division to find what is the quotient. X minus a, what is left over q of x. And then we repeat it and repeat it and repeat it until our polynomial is made up of only factors of x. So in our first example, we are given a polynomial, and it is x cubed plus 4x squared plus x minus 6. So I look at my constant. It is -6. What are the factors of 6? 3 and 2 are 2 possible factors. What other terms? 1 and 6. 1 and the number itself are always going to be possible factors. We also need to remember that it's possible that these could be integers that are either positive or negative. So plus or minus, plus or minus, plus or minus, plus or minus. This is my starting point. I have a leading coefficient of 1, so this tells me that I'm done. I have found all the possible integers that could be factors. And now we essentially guess and test using what we have. And we always start with the smallest ones because we are quote unquote lazy mathematicians and we don't want to do too much work. If my factor is x minus 1, what do I put into my equation? P evaluated at what point? 1. Okay. your notebook has lots of space for you to do this. But if I did it on my screen, I would have to scroll back and forth, which I'm not going to do. So you can see here, it says exactly what I just said. If x minus 1, then we substitute x equals 1. And what is the function? This is going to be 1 cubed plus 4 times 1 squared plus 1 minus 6. Okay, and if you look at the next page, it does it for B, C, and D. But because I don't want to scroll, I'm just going to zoom in here. You guys can write it out into your notebook, but I want to make sure we can see everything that we're doing all together. Okay, some mental math. 1 plus 4 is 5, plus 6, or sorry, plus 1 is 6, and then minus 6, this will give me 0. This one works. Yay, we did it. Okay, let's look at the next one. If the factor x minus 2 exists, then I need to evaluate the function at positive 2. So again, some mental math. If I'm replacing what I see there with a positive 2, this is going to be 2 cubed, which is 8, plus 4 times 2 squared. This gives me 16, and already I know it's not going to work because the next number is a plus, and the only thing I'm minusing is a 6. So this is obviously not going to be 0. So this is not a factor. Okay, let's test this one. If x plus 2 is a factor, then I need to test the function at negative 2. So negative 2 cubed plus 4, negative 2 squared plus negative 2 minus 6. This one looks a little bit more promising. This is negative 8 plus 16 minus 2 minus 6. And this does simplify to 0, so this is a factor. Next one we try is x plus 3. So again, I'm going to put in here x equals negative 3. This is going to give me negative 27 plus 4 times 9 is 36 minus 3 minus 6. And if my mental math is correct, this also gives me 0. All right, we have found the factors. Why am I stopping? Why don't I test the rest of them? What's my degree? 3. What is the maximum number of roots I can have? 3. How many roots did I find? 3. So I'm done. I stop. Okay, so you are looking for roots, or in other words, factors or x-intercepts of a polynomial. Pay attention to the key features we already know. This is a degree 3, so we cannot have more than 3. So once you find 3, stop. You're done. Okay, now this part of your notes is essentially exactly what we just did, just written out step by step, so I'm not going to worry about it. But in this last section here, I'm going to rewrite the function. P of x is x minus 1 times x plus 2 times x plus 3. So that's our original function rewritten. All right, in example 2, we are going to look at using the theorem in order to test it again. So looking at our function 2x cubed plus 3x squared minus 3x minus 2, what is the factors? What are the possible factors that I can have? So I'll rewrite the function down here, and I'll follow along with your workbooks because I think this one will be easier to see. My constant is a negative 2. So that means I'm listing the factors of 2. What are they? Plus or minus 1, plus or minus 2. However, in this case, I have a leading coefficient. My leading coefficient is a 2. What this tells me is that take all of your factors and divide them by a leading coefficient, and you're going to get another set of possible factors. So if I have plus minus 1, plus minus 2, and if I divide them both by 2, this gives me plus minus 1. I already have that, so I don't need it. But this tells me that plus or minus 1/2 is also a possible factor. Usually we won't need to worry about the fraction factors because we'll be able to pull them out at some point using easier methods. But something for you to know. The possible factors are the factors of the constant, and if there's a leading coefficient, you got to divide them by the leading coefficient to find any other ones that you've got. Okay, plus or minus 2, plus or minus 1. Let's test positive 1. If I put positive 1 in here, I will get 2 plus 3 minus 3 minus 2. This equals 0. Hooray! So, since the function evaluated at 1 is 0, that means my factor is x minus 1. If x minus 1 is a factor, what is the quotient? So let's use synthetic division because it's a little bit quicker. Look at my coefficients, 2, 3, -3, -2, and I am testing, or I know the factor or the root is 1. I drop the first number. I multiply times the root. I'm going to get 2. And then I add, gives me 5. Multiply the root. 5. When I add them, I get 2. Multiply times the root. The root is 1, so this is 2. I get 0. Hooray! So that means my polynomial can be rewritten as the following. P of x equals x minus 1 is the root, 2x squared plus 5x plus 2 is what's left over. What kind of a polynomial is this? What's the degree? What's the degree? Which means it's a quadratic. Let's use our magic numbers. 2 numbers that multiply to 2 times 2 is 4. And 2 numbers that add to positive 5. What numbers do I need? 4 and 1. I have a leading coefficient. What do I do with it? Divide by 2. So my other 2 factors are 2 and 1/2. Well, there's the fraction. And this is where the fractions can come out in easier methods if you use them this way. Okay, so let's put them all together. X minus 1, x minus 2, 2x minus 1. These are my 3 factors of the polynomial. All right, so the constant gives you a starting point, and the starting point is there to make it factorable using easier methods. Okay. This is just identifying and connecting the fact that, or part B, is saying that if you know the factors, then these also represents the x-intercepts. All right, so given our polynomial function, the x-intercepts are at x equals, oh, where did I go? Oh, my screen is frozen. There it is. 1, 2, and 1/2. All right, next one. Here we have a high degree polynomial, x to the 4th. Okay, looking at my constant term, it is negative 18. What are my possibilities? I'll start you off. Plus minus 1, plus minus 2. Then 3, 6, and 18. Lots of possibilities. I have a leading coefficient of 1, so I don't have any fractions in this particular, or I don't have any fractions that I can test. Okay. Let's check positive 1. If I put a positive 1 in, I get 1 plus 3 minus 7 minus 27. Okay, I already know this is not going to work. My negative numbers are bigger than my positive numbers, so this is not going to work. Let's try P of negative 1. What happens when I do a negative to an even power? It becomes a positive number, and so therefore if it's to raise to an odd power, then it's negative. So this is positive 1, negative 3, minus 7, positive 27, minus 18. Right, because all the x's are 1, and I'm just looking at the sign. If you see an even degree, that's going to give you a positive sign. A negative degree gives you a negative 1. Sorry, odd degree gives you a negative 1. Does this work? Yes? Awesome. Okay, since p of negative 1 equals 0, then my first factor is x plus 1. Again, let us use some synthetic division, figure out what's left over. So my coefficients are 1, 3, negative 7, negative 27, and negative 18. And I'm doing the point plus 1, or sorry, negative 1. I drop the first one, multiply by the root, add together. Multiply by the root, add together. Multiply by the root, add together. Multiply by the root, and I get down to 0. Okay, so now my remainder is this, x to the power 3 plus 2x squared minus 9x minus 18. So this is what my function looks like, x plus 1, x cubed plus 2x squared minus 9x minus 18. Here we are. Now, in order to factor this further, I could take another factor, start testing points, and you can use the factor theorem again. However, I want to try something. I see an even number of terms. I'm going to try factor by grouping first before I do the testing. Because if I can do factor by grouping, that's much quicker than doing testing of points, right? If I do factor by grouping, factor by grouping, then let's just focus on the highlighted bit. I can factor not a 2, but I can factor an x squared out. And that will leave me with x plus 2. On the other side, I can factor a negative 9 out. That leaves me with x plus 2. Okay, that works. So x plus 2 and x squared minus 9. So P of x is x plus 1, x plus 2, x squared minus 9. I still have square. Anyone notice anything special about the last bracket? Difference of squares, yes. So Difference of squares. When we have two perfect squares with a minus sign between them, we can automatically factor them into two pieces that look like that. What's my b value here? 3. Okay. So we have used pretty much every factoring method that we know in order to factor this fully. X plus 3, x minus 3. All right, we're done. We've factored this fully. Any questions about this example? No? Okay, let's do one word example and then we are done for today. Okay. Okay, an artist creates a carving from a block of soapstone. The soapstone is in the shape of a rectangular prism whose volume is in cubic feet, represented by the volume equation V of x equals 6x cubed, 25x squared, 2x minus 8, where x is a positive real number. What are the factors that represent possible dimensions of this block? Remind me, what is the volume of a rectangular prism? Length times width times height. So what we are looking for is x minus a, x minus b, x minus c. What they have given us is this expression, but expanded. We want to put it back into factored form in order to be able to tell what are the lengths, width, and height. Okay, looking at this equation, my constant number is a -8. So my constant is a -8. So my possible factors are, I'll start you off, plus minus 1, 4 and 2, more, 8. Good. Let's also do this quickly in our heads. If I put positive 1, I'm going to get 6 plus 25 plus 2 minus 8. So 1 does not work. If I do -1, all that does is change the signs, right? -6 plus 25, -2 minus 8. Does that work? No, it does not. Okay, so the ones are no good. Okay, let's try 2s. If I put a 2 here, big number, positive, big number, positive, big number, positive, small number, negative. This is not going to be 0, right? Let's try -2. If I do -2, this is going to be, oh my gosh, let's use a calculator. Make our lives easy. 6 times -2 to the power 3 plus 25 times -2 squared plus 2 times -2 minus 8. Oh my goodness, it didn't write this correctly. 3 plus 25 times 4 minus 4 minus 8. Okay, plus and minus 1, no good. Plus and minus 2, no good. Let's see. If I put a positive 4, I'm going to have the same problem with a positive 2. I'm going to have lots of big positive numbers, so positive 4 is not going to work. Let's try -4. 6 times -4 to the power 3 plus 25 negative 4 squared plus 2 times negative 4 minus 8. Oh, hooray, we found one. Okay. Negative 4 works. So I'm going to make a note here. Calculator tested plus minus 1 plus minus 2 plus 4. Why not? It's gone. Okay, let's try again. Can you see it now? Okay. Let's finish up, guys. So calculator, we know the positive numbers are not going to work. The smaller positive numbers didn't work. The negative 4 using our calculator did work. So we want negative 4 to be a factor. So let's do synthetic division and sort this out. This is 6, 25, 2, negative 8. Drop the first number. This is a 6. Multiply by the root. This is negative 24. Add them together. Multiply by the roots. Add them together. Multiply them by the roots. Add them together. So our volume, we can say x plus 4 is one of the dimensions. And then we have 6x squared plus x minus 2 are the other two. This is a quadratic. So two numbers that multiply to negative 12 and add to 1. What are they? Negative 4 and 3? No. Positive 4, negative 3. I have a leading coefficient, so I have to divide them by 6 and reduce. This gives me 2/3 and negative 1/2 are the other two that are going to work. So x plus 4, 3x plus 2, 2x minus 1. This is our length, width, height. This was supposed to go in here. I'm not filling in all the blanks because I'm just writing it all together. Any questions how I did this? Okay, your homework for today, 2 things. 1 page in notebook. So flip over your page. Those are your practice questions for today. And we are going to watch lesson 7 online tonight. It's already posted. Tomorrow, we're going to do a work block to prepare for our quiz on Thursday. Okay, so in class, you have a few questions. Here they are, just 1 page. Okay. Your homework tonight when you go home is to do the next lesson. And we're going to do a dedicated work block tomorrow.